Common pitfalls of the scientific methods. The scientific method is often heralded as the gold standard for inquiry and discovery, providing a structured approach to understanding the natural world. However, despite its esteemed reputation, the scientific method is not infallible. Researchers, educators, and students alike can fall prey to various pitfalls that can compromise the integrity of their findings and conclusions. Understanding these common pitfalls is crucial for anyone engaged in scientific inquiry, as it not only enhances the quality of research, but also fosters a more informed public discourse about science. In this article, we will explore 4 significant pitfalls of the scientific method: confirmation bias, over-reliance on statistical significance, neglecting the importance of replication, and misinterpretation of results. Confirmation bias, the researcher's blind spot. One of the most pervasive pitfalls in scientific research is confirmation bias, which occurs when researchers favor information that confirms their pre-existing beliefs or hypotheses while disregarding evidence that contradicts them. This cognitive bias can lead to skewed data interpretation and ultimately flawed conclusions. When scientists approach their research with a predetermined notion of what they expect to find, they may unconsciously design experiments or select data that aligns with their expectations. For example, a researcher investigating the effects of a new drug may focus solely on data that shows positive outcomes while overlooking negative side effects or no results. This selective attention not only undermines the validity of the research, but can also have dire consequences in fields such as medicine, where biased findings can lead to ineffective or harmful treatments being approved for public use. To combat confirmation bias, researchers must adopt a more rigorous approach to their methodology. This includes actively seeking out disconfirming evidence and considering alternative explanations for their findings. Peer review processes can also serve as a safeguard against this bias by introducing external scrutiny that challenges researchers to defend their conclusions against opposing viewpoints. Over-reliance on statistical significance, the misleading metric. Another common pitfall is the over-reliance on statistical significance as a measure of research validity. In many scientific fields, a p-value of less than 0.05 is often considered the threshold for significance. However, this binary approach can be misleading and may encourage researchers to prioritize statistical significance over practical relevance. A statistically significant result does not necessarily imply that the effect is meaningful or applicable in real-world scenarios. Moreover, focusing solely on p-values can lead to p-hacking, where researchers manipulate data or experiment conditions to achieve statistically significant results. This practice not only distorts the true nature of the findings, but also contributes to a growing crisis of reproducibility in science. Studies that cannot be replicated raise questions about their reliability and can erode public trust in scientific research. To address this issue, scientists should emphasize effect sizes and confidence intervals alongside p-values. By providing a more comprehensive view of their results, researchers can better communicate the practical implications of their findings and avoid misleading interpretations based solely on statistical significance. Neglecting the importance of replication, the reproducibility crisis. The principle of replication is fundamental to the scientific method. It allows researchers to confirm findings and build upon existing knowledge. However, many studies are published without sufficient emphasis on replication, leading to what has been termed the reproducibility crisis. High-profile cases have emerged where once celebrated studies could not be replicated, casting doubt on their validity and raising concerns about the robustness of scientific claims. The neglect of replication can stem from various factors, including publication bias, where journals prefer to publish novel findings over replication studies. This creates an environment where researchers may feel pressured to produce groundbreaking results rather than validating existing work. Additionally, funding agencies often prioritize innovative research over replication efforts, further exacerbating the issue. To mitigate this pitfall, the scientific community must recognize the value of replication as an essential component of research. Journals should create incentives for publishing replication studies, and funding bodies should allocate resources specifically for this purpose. By fostering a culture that values replication, we can enhance the reliability of scientific findings and ensure that knowledge is built on a solid foundation. Misinterpretation of results. The communication gap. Finally, misinterpretation of results poses a significant challenge in effectively communicating scientific findings to both the academic community and the general public. Researchers may present their results in ways that are overly simplistic or sensationalized, leading to misunderstandings about the implications of their work. This is particularly problematic in fields such as climate science or public health, where miscommunication can influence policy decisions and public behavior. Moreover, journalists and media outlets often play a role in amplifying these misinterpretations by prioritizing attention-grabbing headlines over nuanced reporting. The result is a disconnect between what research actually shows and how it is perceived by society at large. To bridge this communication gap, scientists must take an active role in disseminating their findings accurately and responsibly. This includes engaging with media outlets to provide context for their research and ensuring that complex concepts are conveyed in an accessible manner. Additionally, fostering collaborations between scientists and communication experts can help create effective strategies for public engagement. In conclusion, while the scientific method remains an invaluable tool for advancing knowledge, it is essential to recognize its limitations and potential pitfalls. By addressing issues such as confirmation bias, over-reliance on statistical significance, neglecting replication, and misinterpretation of results, we can enhance the integrity of scientific inquiry and foster a more informed society. Ultimately, acknowledging these challenges not only strengthens the scientific community, but also empowers individuals to engage critically with scientific information in an increasingly complex world.